The singleton design pattern is one of the most fundamental and widely discussed patterns in software design. Its primary goal is simple yet powerful: to ensure that a class has only one instance and provides a global point of access to that instance. While the idea may sound straightforward, the way singleton is applied has evolved significantly in modern software development. Traditionally, singleton was implemented by making a class constructor private and exposing a static method that returns the same instance every time. This approach ensured that no matter how many times the class was accessed, only one object ever existed in memory. Early applications used this pattern for logging, configuration handling, and resource management. However, as applications grew in size and complexity, developers began to realize that manual singleton implementations often caused more problems than they solved. Issues such as tight coupling, difficulty in unit testing, hidden dependencies, and uncontrolled global state became common. This led to misuse of singleton as a replacement for global variables, which is considered a poor design practice. In modern enterprise frameworks like ASP.NET Core, the concept of singleton has been redefined. Singleton is no longer about writing static code. It is about controlling the life cycle of shared services using dependency injection, DI. Instead of the class managing its own instance, the framework takes responsibility for creating and maintaining a single shared instance throughout the application's lifetime. This modern approach provides several advantages. The singleton's lifecycle is managed by the framework, making it easier to test, replace, and maintain. Dependencies are explicit rather than hidden, and the risk of global state misuse is significantly reduced. As a result, singleton becomes a safe and intentional architectural decision, not an accidental one. In enterprise systems, singleton is best suited for infrastructure-level services, components that naturally exist once per application. Examples include configuration managers, logging services, caching layers, message queue clients, security token validators, and notification services. These components are typically stateless, thread-safe, and expensive to create, making them ideal candidates for a single shared instance. It is equally important to understand what singleton should not be used for. Business logic, database contexts, request handling, and user-specific data should never be singleton. These areas require isolation and scalability, which are better served by scoped or transient lifetimes. In summary, the singleton design pattern is not outdated, it is misunderstood. When used correctly in modern frameworks, singleton provides efficiency, consistency, and clean architecture. Understanding when and how to apply singleton is a critical skill for any developer aiming to build scalable, maintainable, and enterprise-ready applications.